Download this code from codegive.com, link in the description below. OK, let's dive into the world of Angular signals, explore their potential to replace zone.js, and understand how this shift might impact component design. Understanding Angular signals. At their core, Angular signals are a reactive programming primitive. They represent a value that changes over time, and they automatically notify interested consumers when that value changes. This reactivity is what makes them so powerful. Key concepts. Signal a function that holds a value. You can get the value of a signal, read only, and set the value of a signal, mutable. Signals are at the heart of the reactivity system. Writable signal a specific type of signal that can be both read and written to. You can use the set method to change its value directly or the update method to modify the value based on its current state. Computed a signal whose value is derived from one or more other signals. When the dependencies of a computed signal change, the computed signal automatically recalculates its value. Computed signals are read-only. Effect a function that runs whenever one or more signal values change. Effects allow you to perform side effects based on signal changes, example logging, updating the DOM imperatively, etc. Use effects sparingly as they can create complex code if not handled carefully. Why signals matter, and their zone.js implications. Angular has historically relied heavily on zone.js to detect changes in the application. Zone.js is a complex library that monkey patches various browser APIs to intercept asynchronous operations, example set timeout, add event listener, promise resolution, etc. When one of these patched APIs triggers, zone.js triggers Angular's change detection cycle. While zone.js has been essential for Angular's automatic change detection, it also has some drawbacks. Performance overhead. Monkey patching adds overhead to every asynchronous operation, even if those operations don't actually require Angular to update the view. Complexity. Zone.js can be difficult to understand and debug, especially when dealing with complex asynchronous flows. Debugging challenges. Errors inside zone.js can be harder to trace back to their origin. Larger bundle sizes. Zone.js adds to the overall size of your application bundle. Signals as a potential zone.js replacement. Signals offer a more fine-grained, explicit, and predictable change detection mechanism. Instead of blindly running change detection on every asynchronous operation, signals allow you to selectively trigger updates only when specific data values change. The idea is that by using signals, Angular can potentially reduce or even eliminate the need for zone.js entirely. This could lead to improved performance. Fewer unnecessary change detection cycles result in faster and more efficient applications. Simplified architecture. A more direct and understandable data flow based on signals. Better debugging. Easier to trace changes and debug reactive flows. Smaller bundle sizes. Removing zone.js reduces the application's size. Opt-in granular change detection. Developers have explicit control over when and how components update. Will zone.js become deprecated? Angular is actively experimenting with zoneless mode. As of Angular v17, you can create an application without zone.js. However, zone.js hasn't been officially deprecated, and it might not be entirely gone for a while. Here's a probable evolution. 1. Opt-in zoneless applications ** as we have today, with signals fully operational. 2. Improved tooling and guidance * providing developers with the necessary tools and patterns for effective zoneless development. 3. Zone.js as an optional dependency * allowing developers to explicitly choose whether or not to include zone.js. 4. Potential deprecation * eventually, zone.js might be deprecated, but this is likely a long-term goal. How signals impact component design. Signals fundamentally change how you manage state and trigger updates in your components. Here's how. State management with signals * instead of using traditional properties that are updated directly, you store your component's state in signals. This makes the state reactive and enables automatic updates. Reactive templates * you can bind directly to signal values in your component's template. Angular will automatically update the template whenever the signal value changes. Event handling and updates * you update signals in response to user events or other asynchronous operations. Side effects use effect functions to perform side effects when signals change, such as updating a chart or sending data to a server. Code examples. Let's look at some examples to illustrate how to use signals in components. Example 1. Simple counter component. Explanation * 1 signal, 0, * creates a writable signal named count and initializes it to 0. This is our reactive state. 2 computed, equals this dot count, * 2, * creates a computed signal named count. Its value is always twice the value of count. Whenever count changes, count is automatically recalculated. 3 increment, and decrement, * these methods update the count signal using the update method. Update takes a function that receives the current value of the signal and returns the new value. 4 template binding * in the template, we use count, and count, to display the values of the signals. Angular automatically subscribes to these signals and updates the view whenever their values change. Example 2, input and output signals. Explanation * 1 input string, default name, * creates an input signal. Input signals are used to pass data into a component from its parent. The string type argument specifies that the signal holds a string value. The default name argument provides a default value. 2 output string, * creates an output signal. Output signals are used to emit data from a component to its parent. The output signal must be called with emit, to trigger updates. 3 component communication * parent component passes in the parent name variable through the appName editor tag. When name changed is emitted, the parent component can update its state accordingly. Example 3, using effect. Explanation * 1 effect, equals. * the effect function registers a callback that will be executed whenever any of the signals read inside the callback change. 2 console.log, value changed, this .value, * in this example, the effect logs the new value to the console whenever the value signal changes. You could replace this with any other side effect, example updating a DOM element directly, making an HTTP request. Important considerations. Side effects in effects * use effect, carefully. They can make your code harder to reason about if you're not disciplined. Avoid complex logic in side effects. Performance * while signals are generally more efficient than zone.js based change detection, you can still create performance problems if you have too many signals or complex computed signals. Mutations * prefer immutable updates. Use .update or .mutate when working with arrays and objects stored in signals to ensure correct change detection. In summary, Angular signals provide a powerful, fine-grained, and explicit way to manage state and trigger updates in your applications. While zone.js might not disappear overnight, signals are paving the way for a more efficient and predictable Angular architecture. By understanding signals and adopting reactive patterns, you can prepare your applications for the future of Angular and unlock significant performance and development benefits. Embrace the change, experiment with signals, and get ready for a new era of reactivity in Angular.